The derivative of, well, and I kind of appreciate that you said that, be like x prime y, but x prime is
Well, dx dt.
1. Then we're not assuming they're functions of t. There's nice, good old x and y. Right? No, I didn't put anything up there about some parameter in the background. Plus xy prime, right? But of course, x prime is just 1. Right? The prime now notation, I can really only use that when I know it's with respect to x. Right? So that's the only time I could really use that. Plus, how'd you do this piece?
2 pi y times y prime.
Yeah, y prime, I like it. So that y prime, guys, is like the chain rule piece. It says that y in the inside gets a turn, right? Minus 1 equals 0. Now notice where are all my y primes? My y primes are on this guy plus this guy. That's my y prime stuff, right? Because we all know the next step is to try to get your y prime stuff together so you can divide by the crap you don't want. Get y prime by itself. Where's my not y prime stuff? It'll be 1y, so it'll be y cosine xy minus 1. Now, let me see something interesting here. Look back up here. Let's say that this piece, and this is what I said earlier, this is like the f of xy. How are we doing there? That's f of xy, right? And it happens to equal 0. Normally it could equal z if equal anything, but this is just saying equal to 0. What is fx? What is that? Yeah, it'd be cosine xy times y, right? Because y is a constant now. That's a constant, minus 1. And what's fy? Yeah, it'll be x cosine xy plus 2 pi y. And of course, that's a constant. So what's this? Fy, right? And what's this? Fx. So what we really have happening here is this is Fy times dy dx. So let me say it like this, df dx. And this is fx times dx dx. Because dx dx was that 1 that we kind of killed earlier, right? How are we doing? Equal to. So we sort of have a quicker way, believe it or not, to get to the answer. Because what do we do after this? Don't we subtract that and divide by that to get the y prime? Right? So what we can do now instead, more directly, is if I have so it'll be, what will be on the top? It'll be the fx, right? In fact, it'll be the negative fx on the top. So I'm going to make this capital to make it clear. This will be fy, or I'm sorry, df, how do I want to say that? Yep, dy dx. What will be on the top is this piece. You're going to subtract that bad boy over, so it's going to be negative fx on the top. And on the bottom is going to be divide by the fy. So that's kind of a cool, quick way to do it, right? For the simpler ones, it's not that much less work, but for the more complicated implicit, it's a lot easier to do partials than it is to do truly implicit differentiation. Because it's so easy to figure that y prime at the right place. Partials, I don't have to worry about that at all. I just treat the one variable like a constant and then go to town on the other variable. It's a lot easier mentally for me to do this. So if I had, for example, I don't know if you guys remember what this is. If I pull that 25 over, in this case it's not that important because it's a constant, but this would be my, like my function, my f. What's fx? And what's fy? So what's dy dx? Negative 2x over 2y. I'm sorry, 2y over 2x, sir. Which is negative y over x. I don't know if you remember, that's what you get for a circle, right?
Why is 2y over 2x. I thought it was 2x.
Oh, yeah, that's what I had it right in the first place. My bad. Yeah, because it's fx over fy. Cool. Very nice. So then you get that thing that we've gotten before, the negative x over y, but that was a little bit quicker, but you can imagine for a much harder equation, I'd rather do it with partials than with truly implicit differentiations, just a little bit quicker. So let's do this. I do have, just like last time, a little thing to work on in groups or by yourself if you want. So let's get started on that a little bit, and then we'll take a break. Actually, let's take a break now. Let's take just about till 40 after, right? A little bit less than last time. When you get back, we'll try out this little quiz thing, and then we're actually going to get into section 12.6.
Yeah, you have this.